sklearn, linear model, logistic regression CV. A detailed exploration. sklearn, linear model, logistic regression CV is a powerful and flexible tool in scikit-learn for performing logistic regression with built-in cross-validation. It allows you to find the optimal hyperparameters for your model, leading to better generalization performance on unseen data. Understanding the basics. Logistic regression. This is a statistical model used for binary classification. It predicts the probability of a data point belonging to one of two classes, e.g. spam not spam, positive negative. The model works by fitting a linear decision boundary between the classes. Cross-validation. This technique helps to estimate the model's performance on unseen data. It involves splitting the data into multiple folds, training the model on a subset of the folds and evaluating its performance on the remaining fold. This process is repeated for each fold, providing a more reliable estimate of the model's generalization ability than a single train test. Split. Hyperparameter tuning. Hyperparameters are parameters that are not learned from the data, but instead need to be specified by the user. In logistic regression, these include the regularization strength C, the solver used for optimization, and the penalty type L1, L2. Elastic net. Logistic regression CV automatically searches for the best values of these hyperparameters using cross-validation. Key parameters and their explanation. YAML. Key parameters with their default values and descriptions. CV integer. Cross-validation generator or iterable. Default none. C's list of floats. Default 10. Penalty L1. L2. Elastic net. Default L2. Solver Newton CG. LBFGS. Liblinear. SAG. Saga. Default LBFGS. Toll float. Default 1e-4. Maxiter int. Default 100. Classweight dict or balanced. Default none. njobs int. Default none. Verbose int. Default 0. Refit bool. Default true. Random state int. Random state instance or none. Default none. Intercept scaling float. Default 1. Multiclass OVR. Multinomial. Default OVR. Dual bool. Default false. Fit intercept bool. Default true. Warm start bool. Default false. L1 ratio float. Default none. Selection cyclic. Random. Default cyclic. Max features int. Float or auto. SQRT. Log 2. Default none. Detailed explanations for each parameter. CV. This parameter controls the cross-validation strategy. You can specify an integer, e.g. 5 for 5-fold cross-validation. A cross-validation generator, e.g. stratified k-fold. Or an iterable. If none, it defaults to 5-fold cross-validation. Sees a list of regularization strengths to be evaluated. It specifies a range of values for the parameter C inverse of regularization strength. Default value is 10, which means the algorithm will explore 10 different values for C. Penalty. The type of regularization penalty to apply. L1 regularization lasso forces some coefficients to be exactly 0 feature selection. L2 regularization ridge shrinks coefficients towards 0, but does not force them to be exactly 0. Elastic net. A combination of L1 and L2 regularization. Solver. The optimization algorithm used to find the optimal coefficients. Newton CG. Newton conjugate gradient for large datasets and L2 penalty. LBFGS limited memory. Broyden Fletcher Goldfarb Shano, good for large datasets, but slower than SAG. Liblinear suitable for smaller datasets and L1 or L2 penalty. SAG stochastic average gradient, good for large datasets and L2 penalty. SAGA similar to SAG, but supports all penalties L1. L2. ElasticNet. Told the tolerance for the optimization algorithm. Maxiter the maximum number of iterations for the optimization algorithm. Class weight. This parameter handles class imbalance. None. No class weighing. Balanced automatically adjusts weights inversely proportional to class frequencies in the input. Data. Dictionary manually specify weights for each class. N jobs the number of parallel jobs to run. If none, it uses all available processes. Verbose controls the verbosity of the output. Refit if true. Fits the model on the whole dataset using the best hyperparameters found during cross-validation. Random state controls the random number generation for reproducibility. Intercept scaling the scaling applied to the intercept term. Multiclass the method used to handle multi-class problems. OVR1 vs REST approach. Multinomial logistic regression. Dual whether to use the dual formulation of the problem. Fit intercept whether to include an intercept term in the model. Warm start whether to use the previous solution as a starting point for the optimization. L1 ratio the mixing parameter for ElasticNet regularization. Selection the strategy for choosing features in the SAG and SAGA solvers. Max features the maximum number of features to use for each iteration in the SAG and SAGA solvers. Advantages of using LogisticRegressionCV. Automatic hyperparameter tuning finds the optimal hyperparameters for your model, improving its performance. Cross-validation provides a robust estimate of the model's generalization performance. Regularization reduces overfitting by shrinking the coefficients towards zero. Class weighing handles imbalanced datasets by adjusting weights for different classes. How to use LogisticRegressionCV. Python. From sklearn, linear model import LogisticRegressionCV. From sklearn, datasets import load iris. From sklearn, model selection import train test split. Load the iris dataset. Iris load iris. X iris. Data. Y iris. Target. Split the data into training and test sets. X train. X test. Y train. Y test train test split X. Y. Test size 0.2. Random state 42. Create a LogisticRegressionCV object with desired parameters. Model LogisticRegressionCV CV5. Cs10. Penaltal 2. Solver LBFGS. Fit the model to the training data. Model. Fit X train. Y train. Make predictions on the test data. YPRED model. Predict X test. Evaluate the model's performance. From sklearn, metrics import accuracy score. Accuracy score test. YPRED. Printf accuracy. Key points to remember. Dataset size. The choice of solver can depend on the size of your dataset. For smaller datasets, liblinear is often a good choice. For larger datasets, SAG or SAGA are more efficient. Regularization experiment with different penalty types L1, L2, ElasticNet to see what works best for your data. Class weights. Use class weight if your dataset is imbalanced to improve the model's performance on the minority class. Cross-validation. Choose a suitable cross-validation strategy based on your data and the desired level of robustness. Conclusion. sklearn, linear model, LogisticRegressionCV is a valuable tool for building accurate and robust logistic regression models. It offers convenient features for hyperparameter tuning, cross-validation, and regularization, making it a powerful and flexible choice for a wide range of classification problems. By understanding the parameters and their implications, You can use this model effectively to solve your specific machine learning challenges.